Something the size of Manhattan just tore through our solar system, and it came from somewhere beyond our sun's reach. Scientists watched it develop a tail like any normal comet as it approached our star, but then something happened that shouldn't be possible. The tail vanished. Not gradually, not slowly, but in a way that has astronomers scrambling to rewrite what they thought they knew about objects from interstellar space. 3I Atlas represents only the third confirmed visitor from beyond our solar system, and it's already breaking the rules. When you've got an object spanning several kilometers doing things that defy conventional physics, people notice. More importantly, they start asking questions that don't have comfortable answers. The Atlas survey system picked up 3I Atlas during a routine scan, but there was nothing routine about what they found. Automated telescopes designed to catch asteroids and comets flagged this object immediately because something about its trajectory screamed wrong. It wasn't following an elliptical orbit around the sun like the thousands of comets and asteroids we've catalogued. Instead, it was moving on a hyperbolic path, which meant one thing. This visitor came from another star system entirely. The size estimates put it somewhere around 10 kilometers across, roughly the length of Manhattan Island. That's massive for an interstellar object. Oumuamua, our first confirmed interstellar visitor back in 2017, was probably only a few hundred meters long. 2I Borisov, the second one, was smaller still. But 3I Atlas dwarfed both of them. And size matters when you're trying to understand what something is made of and how it behaves. Larger objects retain heat differently, respond to solar radiation differently, and fragment differently than smaller ones. Every assumption scientists made had to account for this thing's sheer mass. At first, the classification seemed straightforward. As 3I Atlas fell toward the sun, picking up speed with each passing day, it started developing a tail. Telescopes captured the fuzzy coma forming around the nucleus, the telltale sign of a comet releasing gas and dust as solar heat vaporizes surface ice. Scientists breathed a sigh of relief because finally here was an interstellar object that made sense. Comets, they understood. Comets followed predictable patterns established by decades of observation. The tail grew as the object approached perihelion, the closest point to the sun in its trajectory. Spectroscopic analysis showed the signature of water vapor and other volatiles streaming off the surface, exactly what you'd expect from a comet being heated by our star. Models predicted the tail would reach maximum size shortly after perihelion, then gradually fade over weeks or months as the object retreated into the outer solar system. Researchers prepared their instruments to capture every detail of this interstellar comet's journey, knowing they might never get another chance like this. Then 3I Atlas did something that shouldn't happen. As it whipped around the sun and began its outbound journey, the tail didn't just fade, it disappeared. We're talking about a massive structure of gas and dust, potentially millions of kilometers long, just gone within days of the solar pass. Comets don't do that. When a comet rounds the sun, it's at its most active. The tail should persist, should actually intensify as the surface gets blasted by maximum solar radiation. But observations showed the tail breaking apart, dissipating, vanishing in a way that contradicted every model. Teams around the world checked their data, convinced there must be equipment malfunction or observation error. There wasn't. Multiple independent telescopes confirmed the same thing. The tail was gone, and the object that remained looked more like a bare asteroid than an active comet. The coma surrounding the nucleus faded to almost nothing. Whatever process created that tail had shut off completely, and it happened far too quickly for any conventional explanation to work. This wasn't the first time an interstellar visitor made scientists uncomfortable. Oumuamua, that first confirmed object from beyond our solar system, caused chaos in the astronomy community because it accelerated as it left the solar system. Objects don't just speed up on their own. Either they're pushed by something, or they're rockets with engines. The only natural explanation was outgassing, where vaporizing ice acts like a thruster. but nobody detected any gas, any tail, any coma around Oumuamua. It accelerated anyway. The speculation got wild. Some respected scientists published papers suggesting Oumuamua might be artificial, a light sail or probe from another civilization. Most of the astronomy community pushed back hard against that idea, but they couldn't offer a satisfactory alternative. The object's strange tumbling rotation, its unusual shape, and that unexplained acceleration created a mystery that still hasn't been solved. Now, 3i Atlas brings all those questions roaring back, but with a twist. This object showed clear signs of being a comet, then stopped being one. If you're trying to fit that into conventional explanations, you're going to have a bad time. Either the composition is unlike anything we've encountered, or the physics operating on this object work differently than we understand, or we're missing something fundamental about what interstellar objects actually are. The standard comet model falls apart pretty quickly when you run the numbers. Sure, 3i Atlas developed a tail, but comets don't just turn off their outgassing like flipping a switch. The process is temperature-dependent and gradual. Even if the object rotated to expose a different surface, you'd still see activity from the heated side. Even if it fragmented, which sometimes happens when comets get too close to the sun, you'd see the fragments producing their own tails. None of that happened here. Maybe it's an asteroid then, just a rocky body that had some surface ice that boiled off during the solar approach. Problem is, the amount of outgassing required to produce the observed tail suggests way more volatile material than a thin surface coating. You'd need substantial ice content throughout the object, which makes it a comet by definition. But if it's a comet with that much ice, where did all the outgassing go after perihelion? The heat doesn't just disappear. The sun's radiation doesn't suddenly stop affecting the object. Some researchers proposed that 3i Atlas might have a layered structure, with a thick ice mantle that completely sublimated away during the solar pass, exposing a rocky or carbonaceous core underneath. That could explain the tail appearing and then vanishing, but the timeline doesn't work. Losing several kilometers of ice in a single solar pass would require heat distribution and sublimation rates that don't match our physics models. You'd need the object to basically burn away half its mass in a matter of days, and if that happened, we'd have detected the fragmentation signature. Here's where things get interesting, in the way that makes veteran astronomers nervous. What if 3i Atlas is made of something we don't have in our solar system? Different star systems form under different conditions, with different chemical compositions and temperature ranges. An object forming around a star richer in heavy elements or in a colder molecular cloud with exotic ice mixtures might behave in ways our models don't predict. There are theoretical ice compositions that could remain stable in interstellar space, but react violently to solar radiation in ways pure water ice doesn't. Combinations of methane, ammonia, carbon dioxide, and other volatiles in specific ratios might create a substance that sublimates explosively near the sun, then forms a hardened crust afterward that prevents further outgassing. Nobody's ever seen this happen, because every comet we've studied formed in our solar system from the same basic material. 3i Atlas came from somewhere else, potentially carrying the frozen chemistry of an alien star. Another possibility involves structural integrity in ways we don't fully understand. Maybe the object was already fragmenting before we detected it, held together loosely like a rubble pile. The solar pass could have provided just enough energy to blow away the smaller pieces, which created the tail while the larger core remained intact. This wouldn't be a normal comet fragmentation event with distinct separate pieces, but rather a gradual shedding of material that stopped once only the solid core remained. Then there's the explanation that gets discussed in private conversations, but rarely makes it into published papers. What if 3i Atlas isn't entirely natural? Not a spaceship, nothing that dramatic, but perhaps an object that's been modified or influenced by processes we don't recognize as artificial. The universe is old. Civilizations could have risen and fallen billions of years before Earth formed. What if some interstellar objects bear the marks of ancient engineering, so old and worn that they look almost natural? It sounds like science fiction until you remember that Oumuamua's acceleration remains unexplained. And now we've got another interstellar visitor doing impossible things. What 3i Atlas really reveals is how little we understand about what's actually out there. For decades, scientists assumed interstellar objects were rare, that our solar system was relatively isolated in the galactic neighborhood. Then we developed better telescopes and automated survey systems, and suddenly we're finding these visitors. 3 confirmed in just a few years suggests there might be thousands passing through at any given time. Most too small or too dark for us to detect. Our solar system isn't an isolated island. It's more like a busy intersection on an interstellar highway, with objects from dying stars and planetary collisions, and who knows what else constantly streaming through. Most probably pass unnoticed through the outer solar system, never coming close enough to the sun for us to spot them. The ones we do catch are likely just the largest, brightest examples of a vast population. That should terrify and excite us in equal measure. It means the building blocks of other star systems are constantly accessible if we can figure out how to study them. Every interstellar object carries information about stellar chemistry, planetary formation, and cosmic evolution in regions of space we'll never physically reach. 3i Atlas could be a piece of a destroyed planet, debris from a stellar collision, or a pristine sample of the molecular cloud where another star formed billions of years ago. But it also means our detection and tracking systems are woefully inadequate. We found 3i Atlas basically by accident, and we had only a brief window to study it before it continued on its journey into deep space. By now, it's already beyond the orbit of Jupiter, cooling rapidly, becoming invisible to all but our most powerful telescopes. In a few years, it'll be gone completely, just another dark object in the infinite void between stars. Nobody knows where 3i Atlas came from. Tracing its trajectory backward is complicated because gravitational interactions with the sun and planets alter the path. The best estimates suggest it spent hundreds of thousands, maybe millions of years traveling through interstellar space before randomly encountering our solar system. It could have originated from a star dozens or hundreds of light years away, launched into the void by some catastrophic event we can only guess at. What makes that origin important is what it tells us about other stellar systems. If 3i Atlas is a comet, it means the star system that produced it had volatile, rich material in its outer regions, similar to our Kuiper belt or Oort cloud. If it's made of exotic ices we don't recognize, that suggests different formation chemistry than our sun's planetary disk. Either way, it's a sample from another world, a messenger from a place we'll never see carrying information encoded in its composition and behavior. The scientific community is already pushing for better detection systems. Networks of telescopes specifically designed to catch interstellar objects earlier in their approach. Current systems gave us only a few weeks of useful observation time with 3i Atlas. Imagine if we could detect these visitors months or years out, track them through the entire solar system, maybe even send a probe for close-up study. The data we could gather would revolutionize our understanding of how planetary systems form and evolve. Some proposals suggest parking spacecraft in distant orbits, waiting dormant for decades until an interstellar object approaches, then activating to rendezvous with it. Others want to build a fleet of fast reaction probes that could launch within days of a detection, using gravity assists to catch up with the intruder. The technology exists, but the funding and political will don't. Nobody wants to spend billions on a mission that might wait years for a target. But 3i Atlas proves the targets are out there, and they're weirder than we expected. Each interstellar visitor rewrites the rules a little more. Oumuamua showed us that these objects might not behave like solar system bodies. 2i Borisov seemed more normal, a straightforward comet that happened to come from elsewhere. Now, 3-Eye Atlas demonstrates that even when an interstellar object looks familiar at first, it can surprise us with behavior that defies explanation. The questions stack up faster than answers. What's the actual composition of this thing? Why did the tail vanish so quickly? Is this behavior common for interstellar objects, or is 3-Eye Atlas an exception? How many more of these visitors have we missed because they didn't develop visible tails? What percentage of near-Earth objects might actually be interstellar in origin, misidentified because we assumed everything orbiting through our space was born here? And beneath all those technical questions lurks the bigger, more unsettling one. What does it mean that we share space with so many objects from elsewhere, and we barely notice them? Every day, material from other star systems passes through the space-Earth orbits. Every year, objects that witnessed the formation of alien worlds cut through our celestial neighborhood. We're not isolated. We've never been isolated. We're living in a shooting gallery of interstellar debris, and we've only just started to realize it. 3-Eye Atlas is already gone, continuing its billion-year journey to nowhere in particular. It'll travel through the dark for eons, gradually cooling to the temperature of the cosmic background radiation, invisible and forgotten. Maybe in another 100,000 years, it'll pass near another star, briefly warmed again, possibly developing another mysterious tale for alien astronomers to puzzle over. Or maybe it'll wander the galaxy forever, never encountering another stellar system, a piece of cosmic flotsam with a story nobody will ever fully decode. But for a few weeks in our timeline, it was here, doing something impossible, reminding us how little we actually understand about the universe beyond our tiny bubble of space. The scientists will keep analyzing the data for years, searching for some explanation that fits conventional physics. They might find one. Probably they won't. And 3-Eye Atlas will join Oumuamua in the file of cosmic mysteries we don't have answers for yet. That yet is important. Every impossible thing eventually gets explained, given enough time and data and brilliant minds working on the problem. But until then, we're left with an object the size of Manhattan that grew a tail it shouldn't have had, then lost it in ways that violate our understanding of how matter and energy work. We're left wondering what else is out there, what other impossibilities are streaming through our solar system right now, too faint or too fast for us to notice. And maybe, just maybe, we're left wondering if some of these interstellar visitors are carrying more than just frozen gases and rocky debris. The universe is vast and old beyond comprehension. We've barely started looking beyond our own star, and already we're finding things that don't fit our neat categories and explanations. 3 Atlas passed through our solar system, broke our rules, and continued on without offering any answers. That's not a conclusion. That's an invitation to figure out what we're missing, what we've been wrong about, and what incredible truths might be hiding in the spaces between stars, waiting for us to finally notice.